All right, here we go. Got another video for you. This time it's going to be over inverting linear functions. Well, we're going to look at some relations that aren't exactly linear, and then everything else is going to be a linear function and how you find the inverse or prove inverses between two linear functions. So things to remember, y'all, at their core, inverse functions are just opposites of each other. So if you can kind of remember that inverses are opposites of each other, then the next part is find an inverse you're going to swap x and y. If you can remember that part, then the rest of it is going to make a lot of sense to you. So definitely just focus on swapping x and y to find an inverse. A few things, the inverse of f of x, this is that function notation that kind of means the same thing as y of x, is f to the negative 1 of x. So that's just like a notation thing. Yeah, that's it for now. We're going to make another note whenever we get to example 3. But for now, if you just remember that you swap x and y, you should be pretty well set. So for example, what does that look like? If I have this relation that is plot on this coordinate plane, this has like 4 kind of distinct coordinates. One at -5, -1, another point at -2, -1, one at 3, 4, and finally a point at 6, 4. So these are kind of the distinct points. If I want to find the inverse of this, all I've got to do is find the exact opposite coordinates. So if this was f of x, f to the negative 1 of x is going to have the x's and y's flipped. So I'm just flipping these to find the inverse. So my new point would be at -1, -5. So back 1, down 5. This is my inverted point. Okay, and then I would have one at -1, -2. I can connect those dots. So all I'm doing is taking these coordinates and reversing them. So I'm going to have one at 4, 3. And finally one at 4, 6. Whenever I connect those dots, you can see that that blue line is inverted from the black line. And there's a few things that you could note here, one of which being that this inverse is reflected across y equals x, which is that diagonal line there. And then, yeah, again, the x's and y's are just flipped. Let's talk about finding the inverse in a function itself. So again, whenever we're finding an inverse, if you can remember that x and y trade places, you're going to be doing well. If I'm looking at this function, though, I don't see a y, but you might remember that f of x equals is pretty much the same thing as y equals. So I can rewrite this as y equals 1/5 x plus 3. Then we are going to swap x and y. It's going to become x equals 1/5 y plus 3. So x and y just swap places, and then we are going to now isolate y. Rewrite it as y equals. Okay, so first, this is like step 2, right? Step 1 would be flip x and y. Done. And then we're going to isolate y. So I need to follow the math to get y by itself. And that'll look something like this. I'm going to add or subtract first. So that gives me x minus 3 equals 1/5 y. And then I'm going to undo that 1/5 by multiplying by its reciprocal, its multiplicative inverse. I'm going to multiply both sides by 5, or 5 over 1, because 1/5 times 5, those 5's cancel out, leaving me with just 1 times y, and on the other side I can distribute this 5. Remember, you got to multiply everything by 5, so 5 times x, and 5 times 3. And ladies and gentlemen, that is your final answer. But we're going to write it in function notation, in inverse function notation. So I'm going to rewrite this as f to the negative 1 of x equals, and then 5x minus 15. All right, one more thing. How do we prove that two functions are inverses of each other? Well, for that, to prove inverses, we're going to use something called composition. And that is where we plug one into the other. So basically what I'm going to do is I'm going to take one of these functions and I'm going to plug it in for x in the other one. So that is going to be written technically as f of g of x. And what that means is that I'm taking function f. Function f, remember, is 3x minus 1. And I am replacing the x with the entirety of function g. So instead of 3 times x, it's going to be 3 times x plus 1 over 3. And then minus 1. So what used to be 3x minus 1, 3x minus 1, the whole of function g goes in where that x is, which is what we have here. So instead of 3x minus 1, I've got 3 times g, which is x plus 1 over 3 minus 1. Now I'm going to simplify this, and here is how we figure out if these are actually inverses or not. So 3 times this, you may notice that these 3's are actually going to cancel each other out because it's like a 3 times a 3, kind of the same reason why over here 5 times 1/5 canceled out. I had a 5 in the numerator and a 5 in the denominator. Those cancel each other out, leaving me with x plus 1 minus 1. And then finally, I get f of g of x equals, well, y'all, 1 minus 1 is 0. So all that's actually left over is x. So here's the next thing we need to write. If your composition, which would be f of g of x, meaning g got plugged into f, equals x, then f of x and g of x are inverses. So, since we got an x here, the answer is yes. And that would actually be your final answer. Hey, I simplified that down to x, therefore they are inverses, and the answer is yes. All right, I hope this video is helpful. If you got any questions, obviously you know where to find me in tutoring or in class, and I will see you there.